I'm a little bit nervous about recording this video. I've made my first ever clickbait thumbnail, so I'm going to get thousands of views on this, and so a little bit nervous of all the people watching. If it is your first time watching the channel, then you're in for a treat. Today we are going to be solving maths problems like a lawyer. I'm going to be solving problems like this, and you ask, what does it mean to solve maths problems like a lawyer? Well, to me, there are a certain class of maths problems that if you just gave them to a bunch of different people from a bunch of different professions, lawyers would come out on top by far on this class of problem. And why would they do that? What on earth do lawyers have about them? Well, let's think about what it is lawyers do as a profession. They read the fine print. They follow the letter of the law. They twist the law to their own material gain. We're going to be twisting these math problems to our own gain. They also consider the implications for similar cases, not just the case they're working in. They consider similar cases and think, ooh, what would happen there? What are our actions going to be saying about those cases as well? Can we turn those cases to our advantage as well? They also search hard for loopholes. They're not going to get paid unless they find loopholes. They search hard for loopholes. We are going to be looking for loopholes in these questions. So let's get to the first example. I'll do this one, which is from Senior Kangaroo. That's the extension that you take in your free year and sixth form of the UK Maths Challenge. We'll do this question as an example. We'll solve this like a lawyer. And then once we're done with this example, I'll actually put 4 examples for you to lawyer, and then we'll go through more together. Okay, let's have a look at this then. So we've got a quadrilateral, ABCD, I'm happy with that, where AD is equal to DC. So we'll say those two are the same, that's cool. ADC is a right angle, that's there for us there, and so is ABC, so that's down there. Okay, E is a perpendicular, so there's a right angle there that they haven't drawn. And the length D is 25, they want the area of the whole shape. Okay, but the key here is that this is only one interpretation of the law. And as we know as lawyers, we don't just want to accept one interpretation of the law, we want our own interpretation that gives us material advantage. So let's turn this question into something else. We've got ABCD, but of course we're going to be following the law because we have to do that. ABCD is a quadrilateral. Okay, so we've got a point A to D, so if I put point D down, A to D must be the same length as D to C. So if I put A, D, and D to C down, those two lengths must be the same. Okay, I'm following the law. ADC is a right angle, so I'll put that in, but so is ABC. I haven't put B anywhere yet, but I need to put it somewhere such that ABC is a right angle. So let's put it there, and I make another right angle. But what shape does this make? Well, I hope we can see this makes a square, and also E is the perpendicular from D to AB. Well, that just makes E this point as well, because that's a right angle, because it's a square, and so that length is 25, which means this length is 25, the area of the shape is 25 times 25, and boom, you just got lawyered. So the mark scheme has a really nice way of doing this, considering similar shapes, and it proves some similar shapes, and then it puts the things together. No. We're going to lawyer these questions. That question just got lawyered. Let's do 4 examples, so 4 questions here. Have a look at any of them, try your best with them. Think about working as a lawyer. You are not going to have to do complicated maths here, particularly. You are just going to have to lawyer these questions. And I'll give you a few minutes to think about it. Pause the video, and I'll be back with you in a second. So let's start. Again, pause the video if you want to have more of a think about this. Let's start with question 19, Senior Kangaroo 2015. This question here. I hope you can see as soon as you look at this question that actually this is very similar to the one that I just did. Which is why I've put it first, right? I think we could have all had a good go at this as a lawyer. Let's ignore this interpretation of the law and make up our own interpretation. So we've got, again, quadrilateral ABCD, AD equal to DC, that's the same as what we saw last time, so those two lengths are the same. ADC is also a right angle. Let's put down B such that ABC is also a right angle. Well, that's there. We make another square. AB plus BC is 20, but this is a square, so that means they must all be 10. 10 times 10 is 100, and that will be our answer. So that's the second to last question in a senior extension maths challenge, and we just did 10 times 10. Boom, you just got lawyered. Next question, I think I found this from some random YouTube channel. Angle BAD and angle ADC sum to 90 degrees. Well, okay. Let's just make both 45 then. That's one correct interpretation of the problems. Let's just do that. Let's make them both 45 degrees and draw this picture. I think that's this picture if we interpret 45 degrees each side. And now we're going to find the area of this. Now this isn't trivial, but it's not too bad, because this is a trapezium, right? So what I really want is the height of the trapezium, because that would give me all that I need for the formula to work. But of course, if this is a right angled triangle, because this is going straight down, and this is 45 degrees, then so is that, which means it's isosceles. So this length is the same as this one, even though the picture doesn't really look like it. But this length is the same as this one, so that must be h. And also you can do the same thing over on this side, which means this length must also be h, which means h plus 10 plus h is 20, h is 5, and then we should be good with our trapezium formula. We get the answer of 75. Good. We got that question done then. Another question. Larger semicircle that contains two smaller semicircles. Well done if you got this one. I thought this one was a bit hard. What you need to do here is you need to, again, pretend that the question isn't drawn for you. Look at the question and think, what is the only thing I'm being told? I'm being told there's one big semicircle containing two smaller ones that are drawn along the same base. And the only other information I have is the distance from the point where the two smaller semicircles meet up to the big semicircle is 2. That's all the information that I have, right? We can see that their interpretation, their drawing, has this meeting point slightly to the left of center, but there's nothing in the question that mandates that. It could be a long way to the left of the center like this, or, crucially for us as lawyers, it could be right in the goddamn middle of the semicircle. And that's going to be super helpful if it were, because then if this is from the center and it's distance 2 out to the big semicircle, that means the radius of the big semicircle is 2, which means the radius of the small semicircles are 1, because I'm choosing them to be equal, which means the area of this kind of yellow area here is just going to be the big semicircle, take away the two smaller ones, all of which I know, right? So it's just going to be this maths. I've halved stuff because it's a semicircle. Done 2 of those because there's 2 of them, and it eventually ends up nicely to be pi. Again, there's nice ways to do that considering similar triangles, but doesn't matter. We interpreted the problem in the way that we wanted to, because that's what lawyers do, and then we answered the question very easily. One last one I think to do, and it's really nice that this whole lawyering aspect, it doesn't even require a shape question, right? You can do it on questions like this as well. 4 of the remaining 6-digit integers are always divisible of 7, regardless of the values of the digits. Well, as a lawyer, you read that and you lick your lips, because that just means you can choose whatever the hell you want to be those digits. So let's just choose P to be 1 and Q to be 2, and just pretend that we're given those numbers instead of this absolute confusing rubbish that they've given us. And then all we're going to have to do is get out a bus stop and divide them all by 7 and find the one that doesn't have a remainder. Find the one that does have a remainder. I can't be bothered to animate all of this. If you do this, you'll find that this one is the only one that leaves remainder, and thus is the only one that's not divisible by 7, and we're done. And yeah, that's how you answer maths questions like lawyer. To the thousands of people who have just joined the channel, welcome. You're in a good place. This channel is incredible.